Welcome to a super short explain portion of the video. We're on lesson 1.6, more practice with isotopes and ions. You could use this time to set up your notebook. Today you don't 100% need your notebook in order to be successful, but it would be a good idea to write down any of these examples in case they pop up in the future. So let's jump into a quick review. You've seen this slide before. This bottom right is symbolic notation. Symbolic notation has the element symbol along with the atomic number and the mass number. Now these are really important vocabulary words to know. Mass number is protons plus neutrons. Atomic number is just the number of protons. It also determines the identity of the element. And then finally, to find neutrons, which we will have to do, you're going to do number of neutrons equals mass number, top, minus the atomic number, or the bottom. And the atomic number might look familiar, and you're definitely going to see it for your work today. The atomic number, while on the bottom in the symbolic notation, is actually on the top on a tile of the periodic table. So I'm talking about periodic table, and one thing you should know how to do is how to find any one of these gorgeous elements within the periodic table. So to do this, you're gonna think, okay, what's my element symbol? Then you're gonna find the name, and then you're gonna think, okay, I got my name. Now, what is the atomic number? That's the top number. We saw that on the previous tile. So for example, if I wanted to find the element boron, I'm going to think, okay, boron has a B. So I look in and I see, okay, there's a B right here. And I say, what's that name? Oh, it's boron. Guess what? I knew it. And then let's say I want to know the atomic number because the question asks how many protons are present in an atom of boron. I'll look above it and I see, oh, there are 5 protons because the atomic number is 5. You've seen this before. Isotopes are any atom with the same protons but different neutrons. This is a really classic example. Carbon is one of the most common elements in biological systems. So like in your body, you have a ton of carbon in you. You can see that the bottom number is protons, aka atomic number. The top number changes. Why? Because we have different numbers of neutrons. In the past, you calculated how many neutrons were in here. You see, and to find that, you would do atomic mass, that top number, minus the atomic number, the bottom one. So 13 minus 6, there would be 7. Yeah, I think that's the math. The 7 neutrons, and then 14 minus 6 is 8 neutrons for this isotope. Finally, you're going to need to be able to use a chart in order to find isotopes. So to do this, I need to first know what the chart is telling me. It'll look like this, and it'll say like, oh, okay, first column, there's an atom. Second column, I got protons, number of protons. Mental note, number of protons, you should be thinking atomic number. Third thing, we got number of neutrons, okay. Number of electrons, okay, why would it want me to know protons plus electrons? Well, protons are positives, electrons are negative. These two together, if they're in the same amount, you've got a neutral atom because their positive charge cancels out the negative charge. Not so important right now, but if the question asks which of these atoms is an isotope of another, you need to follow the system. You got to find which atoms have the same protons. For atoms 2, 3, and 4, they have the same number of protons. Next thing I need to do is find neutrons. If they are an isotope of each other, they'll have different numbers for their neutrons. So I look over here and I see 2, 3, and 4. Only 2 and 4 have the same, whereas 2 and 3 have a different number of neutrons. And as a final check, I think if it's a neutral atom, it would have the same number of electrons as protons. And so that 2, and 3 is a set of atoms that are isotopes of each other. This has been a quick review. If you have any questions, come to office hours. Later.